Next, let's spend a few minutes talking about the critical chain method of project scheduling. Now, the critical chain came about in part because the critical path method has a key weakness. It assumes unlimited availability of assigned resources to tasks throughout the course of the project. However, that's rarely the case. Indeed, oftentimes the same resources may be needed for multiple activities, both those on the critical path and those off of it. As such, we may end up having to build inefficient contingencies into each activity in order to combat that issue when using the critical path method. If we know that the exact same team will need to work on the third activity after they finish the second one, we might build in a little extra time for activity 2, knowing that we absolutely need to wait for everyone working on that to finish up their work before we can begin on the next activity. The critical chain goes about dealing with these sort of issues in a different way. Rather than using contingencies at an activity level, the critical chain helps solve this problem by placing buffers at various points in the project path. This strips out those activity-level safety margins and creates some aggregated safety margins instead, which is much more efficient and allows us for additional flexibility in the way that we manage our projects. Buffers help to account for limited resources so that when we do need to wait for those resources to come back available to work on the next activity, we have a way to account for that extra time. However, buffers are also better at dealing with project uncertainties than simply building in contingencies at the activity level could be. After all, at the activity level, we simply throw away any additional time that we might have built in if we don't need it, or we might even have ourselves convinced, based on the way that we've developed our schedule, that work simply can't begin on the next step until a certain amount of time has passed, when in fact, because everything has gone according to plan, and in fact better than plan, we could have gone ahead and moved on to the next activity more quickly. Buffers allow us to address some of the same types of uncertainties that we might see in a project, but do so in a broader sense so that we're able to spread the risk across many different activities. Now, there are two types of buffers in the critical chain system. The first type are project buffers. These are placed at the very end of the critical chain, just prior to the finish of the project. Project buffers help to protect the projected finish date of the entire project from any upstream delays that might occur. However, there's another type of buffer, one that you'll see more often throughout the course of the project. These are feeding buffers. These are added in wherever non-critical activities feed back into the critical chain. So, if we have multiple precedents that need to take place, multiple activities that come before a critical activity, but these aren't themselves critical, then we will place a feeding buffer at the end of this non-critical list of tasks before feeding back in. And the reason we do that is to help protect that critical chain from any delays that are caused by extra time needed with these non-critical activities. Now, in the critical chain methodology, there's not float or slack in the type of way that we saw with the critical path. Instead, all of the float or slack that we might see in these other areas is instead incorporated into the buffers. Now, the size of the buffers that we want to use in the critical chain will vary, as you might expect, based on a number of different factors. Among these is the level of uncertainty in the project. How much risk do we really think we're going to encounter here, or do we not know? If we know less about the project, we'll likely use larger buffers than if we feel fairly confident about the way that everything will unfold. Also, what are the constraints from both preceding and related activities that might help to weigh in on the size of the buffers here? If we know that we have to complete certain activities in a certain order and there's no ability to compress this schedule should things take longer than expected, we might then want some bigger buffers to help deal with that. The same is true when it comes to activities where there might be dependencies down the line. By having a bigger buffer, we can help to keep those activities from being impacted should anything go less than according to plan. Now, buffers are often smaller than the sum of individual activity contingencies, as you might see on a critical path style schedule. It makes sense if you think about it. If we talk about just one activity at a time, it certainly makes sense to build in a bit of a contingency just in case anything goes wrong. However, it's also very unlikely, if you're doing an effective job managing your project and you've planned well and you have a good team, that you would need to take advantage of those contingencies on every single activity. Rather than expecting everything to go wrong, normally we can anticipate just a few things might take a bit longer than expected. If that's the case, then we can aggregate together the combined risk that is associated with each of the different activities and use a buffer that can be tapped just when something goes wrong with any one of these. But again, we don't expect something to go wrong with all of them. Because of that, you can often see buffers that are just half the total sum of contingency that you might have built in using the critical path method. This allows the critical chain method to be seen as more effective and efficient in many cases than its critical path counterpart. The key difference between critical path and critical chain basically gets down to where its management focus is when it comes to the schedule. With a critical path related project, you're really trying to manage the slack or the float for each different activity so that you're never harming anything that's on that critical path. With critical chain projects, on the other hand, you're managing buffers. You're trying to make sure that we still have enough buffer left over to account for any additional risk that we might see later in the project. But again, because it's aggregated, this buffer can apply to many different activities. To visualize this, we see here the same critical path method diagram that we used a few minutes ago. Contingencies can be built in at the activity level, so if anything goes wrong, we have a little extra time to make sure that we don't fall away from our critical path. The critical chain, on the other hand, looks similar, but for the same activities builds in a few additional stops. We see that between C3 and C4, because C3 is a point at which non-critical activities feed back into the critical path, there's a feeding buffer. The same is true going from B3, which is not perceived as critical, into C5. Again, we have a feeding buffer here that ensures that B3 isn't delayed in a fashion that would keep C5 from being able to move forward. Finally, you see the project buffer here at the very end of the project, just before the finish, where C5 enters back in from the critical chain and A4 from non-critical activities along with B3. This project buffer helps to ensure that all three of these activities are completed on time and in a way that doesn't impact our ability to finish our project when we initially anticipated doing so. Now, the critical chain method allows for simpler visualizations of how project work will progress. We really just need to know what the expected durations are and have an idea as to what our buffers might be. But we don't need to go through all of the early start, early finish, late start, late finish, total float, and duration that we need to see with the critical path in order to make sure that everything is just so. Instead, we have a little extra flexibility here in between each activity thanks to the buffers, which means that our focus is really on making sure that those buffers are consistent with our project needs. They build flexibility into how we tackle individual activities and therefore allow us to focus on project work at large. You'll often see that project work is likely to progress more quickly when using a buffer-based methodology for a number of reasons. One, we've stripped out contingencies that might not otherwise be used, but two, think about the human nature of trying to expand a task to fill its entire allotted time. Whenever you're dealing with slack or float, mysteriously, it seems like in many project environments, that slack will suddenly disappear, where suddenly we thought that a task might only take 5 days to accomplish, but if we have 3 more, well, it just might take 8 in total. This is human nature, after all. It's just our ability to kind of procrastinate and keep things from getting done until the last minute. With a critical chain system, on the other hand, all we're doing is picking our pocket in the future if we take too much time on an activity now. That buffer, as it dwindles down, means that we'll have less extra time, less extra comfort zone later on in the project. And so the impetus is always to complete project work as efficiently as possible, knowing that any draw onto that buffer will simply mean that we're going to have to try our best to make it up in the future. From a more optimistic mindset, if we're running ahead of schedule, that's also an opportunity for us to replenish the buffer so that we now have additional ability to combat risk in the future should anything go awry. This can help to lower stress in the project environment later on, knowing that we were able to successfully finish something earlier. Now we've got a bit more time if a challenge arises, and we'll still be able to arrive on time as expected.